This video is a little example of some pointers with the C programming language. Pointers in C can be a bit of a challenge, and this video shows a classic pointer problem from the C puzzle book by Alan Feuer. So let's take a look at the code. So you'll see here that we have three parts to this code. The first part is an array of pointers to characters. So you'll notice how that's being initialized. It's simply being initialized with the literal strings. And so that array would have a size of 4. So it's 4 pointers to char. And remember, literal strings in C have the null character as a terminator on each one of those strings. As you can see in part 2, we're creating an array of pointers to char, and that's being initialized from the pointers to those 4 strings in the part 1. But notice it's doing it backwards. So we're taking C plus 3, which is the base of the array in part 1, plus 3, so it's pushing that forward 3 pointers, if you will. So in essence, it's going to be pointing at first. C plus 2 points at the word point. C plus 1 points at the word new. And C by itself, of course, points at the base of the array. And the first thing in that array is the word enter. So that's an array of 4 pointers to char. Part 3 basically creates just a variable which is set to the same thing that CP is pointing to, but you see it's explicit there that CP is a pointer to a pointer to pointers to char. Okay, let's see if we can go on from here. So here's what that part 1 looks like. So we have this variable C, which is a pointer to this array of 4 addresses. And each one of those addresses, of course, is pointing at a string in the computer's memory, and you notice the null characters on the end there of each of these strings. This is C. The next one then in part 2 is essentially creating another array, and each one of those array elements is pointing to one of the array elements in variable C. And you'll notice how it did it kind of in the backwards order. The last element in array CP is pointing at the first element in array C. And finally then, in part 3, CPP just points at the same thing CP is pointing at. So that's the picture. Now let's take a look at some of the puzzles in the book. The first thing says, let's print the string at that particular address that you see in the green box at the top. So you should stop here for a moment and try to puzzle this out. Basically what it's saying, of course, is it's saying to increment CPP and then dereference what you get when you once you've incremented CPP, and then dereference that next object you get. Now remember, the pre-increment operator there is actually going to change what CPP is pointing at. So it'll actually not only move the pointer, but it actually updates the variable in memory. Okay, let's take a look. So looking at the picture below, we plus CPP, so now it's pointing at the second element there in the array that CP is pointing at. So you'll notice that the dashed line represents the solution here. So CPP is pointing at the second element. We dereference that second element and we get another pointer. That's the red dashed line. And it's pointing then at the third element in array C. And so when we dereference that, we get a pointer to the first element in that array of char, that word point. We get a pointer to that. So if we pass that pointer to printf, it'll start printing the characters at the P, and it'll stop when it gets to the null character at the end. Let's take a look at the next one. Now remember, CPP did get moved, so now it's pointing at the second element of the array CP. Well, this one increments CPP again and dereferences it. So it'll be pointing then at the third element in the array pointed to by CP. That's the yellow line you see there. We dereference that, so we follow the yellow line, and then we minus that. Now remember, we're doing a decrement there. That's the pre-decrement operator. So it's actually going to change what the value is that's stored at that location. So when we minus that pointer, of course, we move it down in the array C. And then we dereference that, which gets us an address, of course. And then what do? We add 3 to that address. So essentially, that pointer to that character array, we add 3 to that, and it knows it's pointing to chars, and so it moves 3 through memory. And remember, zero-based arrays. Okay, see if you can figure out what that's going to do. Okay, here's the solution. So we increment CPP, so now it's pointing at that next location, the dotted lines, and then the yellow dotted line takes us up, and you'll notice how the yellow dotted line now points to the first array element in C because it got decremented. And then we dereference that, and we're pointing at that array of chars there, but we do a +3 on that pointer, so it moves it forward. Now remember, again, zero-based, so the E is at 0, the N is at 1, the T is at offset 2, and the E then is at offset 3, the +3. And it prints that, and of course we get the null character ending the string. All right, let's take a look at the next one. This one takes CPP and it uses a negative offset. In other words, when we're looking at square brackets using the square bracket syntax in C, you can think of those as just offsets. Many people like to think of the element in the square bracket as an index to a particular element in an array, but really it's an offset. Because looking at CPP square bracket -2, you wouldn't say it's an index to the -2 element in the array. It's actually just an offset. So when you look at square bracket notation, think offset. It's a better way to think about it. So if I look at CPP and I think offset -2, well, you can see where CPP is pointing right now. And if I go back 2, essentially I'll be pointing at the same thing CP is pointing at. And then I dereference that, and it comes around, and it's pointing at the last element in C, of course, following that green arrow. Then I do a +3 on that, and it moves me to an offset of 3 in that array of the letters first. Okay? Think about that one. Let's take a look at that solution. So there's the CPP -2 following the dotted line. Then the green dotted line up to array C takes me to the last element in array C. And then that's a pointer. And if I use that pointer with an offset of +3, it gets me to the S. And I print that, and it prints ST, of course, with the null character. All right, let's take a look at the next one. So here we have 2 sets of square brackets. All right, so CPP -1, well, you can kind of imagine by looking at where CPP is, -1 takes us to the element with the red arrow. So we go around to the element with the red arrow, and then we have an offset. Again, don't think of that as an index value, of course. It's an offset. It's a -1. So if I offset -1 from the element, the address that's sitting at the red arrow, I just offset -1 from that. I go to the second element in array C. And then I say +1 on that address, and it's essentially an offset into the array of char with the word new. So I offset 1 into that. Okay, you get the picture there? All right, let's try that solution. There we go. So CPP -1 gets me the green dotted line there. And then I follow the red dotted line, but I do a -1 offset on the red dotted line, taking me to the second element in array C. I +1 that pointer. It takes me to the E. I printf that, and it prints EW. Now with the appropriate spaces in my printfs, you can now pretty much guess what I would print with all these references. Thank you very much.